Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and we are continuing our video series today on algebraic techniques by looking at how to solve two-step equations. Let's get in with a quick recap if you haven't watched our previous video or you just want to recap some of your understanding of algebraic techniques. We'll kick off firstly with some vocabulary, and it's the meaning of solve. So when you are asked to solve an equation, you have the left-hand side of the equation, the right-hand side of the equation, the equal sign in the middle, and we're basically being asked to move algebra from one side of the equal sign to the other so that we can find out the value of the variable. So the variable could be any letter of the alphabet, A, B, C, and so on all the way to X, Y, Z. So if we've got an equation 3a equals 6, for example, we're being asked to find the value of A. Secondly, balancing equations. So we talked in our previous video as an equation being like a set of scales. Whatever you add or take away from one side of the equation, you've got to add and take away from the other side of the equation. And that's really important to remember, that you can't just do an operation on one side. You have to keep it in balance. So you have to do it on the other side as well. And when I say operations, I mean addition, subtraction, multiplication, or division, plus, minus, times, or divide. So whatever you add or subtract or do to one side, you must do to the other. And 3, inverse operations. We're going to see more of that today. Inverse means the opposite. So if something is currently added to this side, to move it across our equal sign, we have to undo that addition. The opposite of add is subtract, and the opposite of multiply is divide. So if something is already multiplied, to undo that, we need to divide it. We're going to see more of that with some of our worked examples. Speaking of which, here's our first one. Solve 17 equals 5x plus 7. Now, in our previous video, we looked at one-step equations. One-step equations are ones where you do one operation only and the equation is solved. In this particular example, we've got to do two things to be able to solve this. Now, the way I like to do solving equations is to firstly have a think about what's going on the left-hand side, what's going on the right-hand side. Have an inspection first. So firstly, on the left-hand side, we can see we've got 17 all by itself. On the right-hand side of our equal sign, we've got two things happening. We've got x, that's our variable that we're trying to solve for. Currently, it's multiplied by 5. That's what this means here. When we've got 5x, there's an invisible times in between the two. We've also got 7 being added. Now, our very first step is going to be try and find a value of x to make the equation true. So that means that x can only be one possible answer. Now, usually, especially in junior maths, your answer is most likely to be a whole number. So if you work it out and it's some sort of a decimal number with horrible decimal places, chances are you've made a mistake. So you should always check that. Now, to do this, what we're going to be doing is collecting like terms. This is a concept we've talked about in previous videos. So we're going to try and get our whole numbers, so that's the 17 and the 7, try and collect them on one side of the equal sign, and any term with a variable, so that's our 5x, get that to the other side of the equal sign. So we're trying to get these apart from each other with the equals in the middle. It's really important to show you're working when we do this. We can often make mistakes in two-step equations. So it's important to show you're working so that if you do make a mistake in one of the steps, at least your teacher can see where you've gone wrong, and you may not be penalised for marks. You may only lose 1 mark out of a possible 2 or 3 marks. So always show you're working, and I'll show you how I set my working out. Your teacher may do it differently. It's always good to be guided by what your teacher prefers, but usually teachers are quite open as long as they can understand what you're doing. Okay, so first of all, I've rewritten this equation underneath. Just makes it easy for me to solve it. Okay, now what I'm going to do first is, what I'm trying to do is get these whole numbers to the same side as each other. I've got 17 on one side already. I'm going to try and move that 7 across the equal sign. Now remember to undo plus 7, because I've got plus 7 here at the moment. To undo plus, I'm going to do a subtraction. I'm going to take it away from this side. But remember, I can't just take it away from one side. I've got to take it away from both. And you can see on my line of working, what I've done is I've lined it up nice and neatly underneath, that I'm subtracting the 7 from both sides. Some people like to do it off to the side in a set of brackets. Other people like to rewrite it as 17 take away 7, 5x plus 7 take away 7 as well. That's fine. That can get a bit messy though. So that's why I like to just line it up underneath. And then what I'm doing is a sum in columns. So 17 take away 7 will be 10. Positive 7 take away 7 becomes 0. So I'm going to be basically getting rid of the 7 and the 7 over here, and I'll be left with just a 5x on that side. So you can see now in these sort of columns where I'm working, the 5x comes down because I didn't change 5x at all. The equal side will come down as well, and then these two sums that I've done, the answers will be present on both sides. Okay, so now I'm left with 10 equals 5x. So I've done the first step of my two-step solving. The second step is to recognize what's going on here now. 5 is being multiplied by the x. To undo times, I have to do a division. So I'm dividing the 5 by the 5 and also doing the same to both sides. Now, some students like to write it as a fraction, 5 over 5, and you'll see cancelling that takes place. Just always remember, it's 5 divided by 5, which becomes 1. Anything divided by itself is always 1. Some students get confused and think it's 0. It's 1. So what I'm left with on this side, on the right-hand side, is just 1x. And on this side, 10 divided by 5 is 2. So I could write this now. I've worked down the left-hand side here to the equal sign, and I'm left with just x. Alternatively, I can write that as x equals 2. Typically, we put our variable on the left-hand side and the answer on the right-hand side, but 2 equals x is the same as x equals 2, so it doesn't really matter how you write it. Let's look at our second worked example. Once again, it's a good idea to start by inspection. So I've got 9 is multiplied by y here, so I've got a multiplication I'm going to need to undo at some point, and I've got a subtraction here, and then I've got the answer here being 10. Now, it's really tempting to start by trying to undo the 9. But what I'm going to have to do here, if I undo this with a 9, I'm going to have to do an 8 divided by 9 and a 10 divided by 9. That's kind of yucky and messy. That's why I always leave the coefficient of the variable, this number here, leave that to your last step. So if you've got a situation like this, your first step should always be to bring like terms together. So we're bringing the whole numbers to the same side with the whole numbers. That's always our first step. So let's start that. We're going to undo take away 8 by adding 8 to both sides. So I add 8 to the left-hand side, add 8 to the right-hand side. So I'm leaving that 9y as my last step. So now I'm going to have over here a negative 8 plus 8, which is the same as plus 8 take away 8. It's going to give me nothing, 0. I've effectively moved that to the other side, which is what I wanted to do. I've brought this term over to this term. But you might say, well, why didn't I just do take away 8 here? And that's because if I did negative 8 and took 8 more away, I don't end up at 0, I end up at negative 16. Have a think of that one. Negative 8, take 8 more away, makes it even smaller as it becomes negative 16. That's why I have to do the opposite. And remember, the sign that goes before the 8 here is always going with the 8 afterwards. So this is actually a whole term together. That's why I have to undo it with a plus. So now I'm going to be bringing down an 18. This will go away, and I'll be left with just a 9y equals 18. Now it becomes much easier to divide both sides by 9. If I try that up here, it would be horrible, but now it's pretty easy because 9 divides nice and evenly into 18. So I'm going to divide the left-hand side by 9, the right-hand side by 9. 9 divided by 9 gives me 1y, and that's equal to 2. My third example today. Now we're looking at some fraction work, but don't be too scared, because let's have a look and inspect over here. I've got 3 times j, and the whole thing's divided by 2. So I'm going to undo this denominator first. Remember, we said to leave the 3j till last. Okay, so we'll undo this first. It's a division here. If anything's in a fraction, it just means divide. So to undo divide, I'm going to multiply. So we're going to be bringing this 2 to the other side through multiplication. So I've rewritten the question now to show you. I'm going to times this side by 2, and then I'm going to times the right-hand side by 2. Now this is where people get a little bit confused. If they do times 2 over here, and they think, well, what's happening here? Well, I'm timesing the top by 2, but then I'm dividing it by 2. So 2 divided by 2 is just 1. This is going to cancel out with this one. Okay, so what I'll be left with on the left-hand side is just a 3j. And then on the right-hand side, 15 multiplied by 2 is 30. Let's look that one through. I could have written this another way. I could have actually done the multiplication. This would become 6j divided by 2 equals 30, but 6 divided by 2 is just 3. So that's another way of doing it there. Now I've got this multiplication that I need to undo, and I'm going to undo that through division as well. So divide both sides by 3, and I get 3 divided by 3, once again, is 1. So I'm left with 1j, and 30 divided by 3 is 10. So 1j, or just j, equals 10. Our final example today, you might want to consider pausing here and see if you can have a go by yourself. But it's the same principle that we had from the last video. In the last example, we dealt with the denominator first, and we're going to do the exact same thing here as well. We've got this denominator here. We're going to bring that to the other side, undoing the division with a times, and then we're going to bring the 7 to the other side as well, undoing the plus with a minus. Now it is tempting to try and do this plus first, but let's think about what this fraction on the left hand side actually is. It's not just m plus 7 divided by 5. It could also be written as m divided by 5 plus 7 divided by 5. So it's not just a straight up 7. It's actually a fraction, 7/5. That's why we get rid of the denominator first. So let's multiply both sides by 5. And then what we're going to do, because we've now got this side multiplied by 5, 5 divided by 5 is 1. So this is effectively going to cancel out. They're going to disappear. So I'm going to be left with m plus 7 all by itself equals 55, because 11 times 5 is 55. So now I've got a single one-step equation left to solve, and this is pretty straightforward. I've got 7 being added. Now I can subtract 7 from both sides, and I'm going to be left with m equals 48. Well, did you find this video helpful? And I sure hope you did. And if you did, why not consider engaging further with us? You could like and subscribe and hit the notifications button so you'll always know when the next algebra video is ready to watch. You could also follow us on Facebook and Instagram. That's where we announce our new videos as well. You could share this video with friends, or even consider telling us in the comments. And if you've got any questions at all about solving equations, you get stuck on something and you can't get in touch with anyone, why not contact us here at mcclutchymaths@yahoo.com. We're always happy to help. Well, thank you so much for watching today. I'm Natalie McClutchy. See you in our next video when we look at 3-step equations. Have a wonderful day.